This question has piqued the interest of man's mind since the time of ancient Greece, where philosophers envisioned the universe in numerous ways. Thinkers from the Pythagorean school, named after the philosopher Pythagoras, believed that the universe was made from numbers. At the center of the universe, they placed a central fire around which the earth, along with heavenly bodies such as the moon, sun, and other planets, revolved. The Pythagoreans believed that the revolutions of these bodies created musical notes that harmonized with the Greek astronomer Aristarchus of Samos had other ideas, however. He believed in heliocentrism, suggesting that the Earth and other planets revolved around the Sun. Nevertheless, the theory that would come to dominate scientific discourse for the next 1,400 years would be the astronomer Claudius Ptolemy's geocentric model of the universe. It placed a stationary Earth at the center of the universe, with heavenly bodies, including the Sun, rotating around it. Unlike the heliocentric model of the time, Ptolemy's geocentric model accounted for the fact that the positions of stars in the night sky seemed to remain the same despite the changing relative positions between the Earth and the Sun. In line with the expectations of the ancient world, the Ptolemaic system described the orbital paths of celestial bodies as being perfect circles. However, certain bodies, such as the Sun and Moon, were observed as having varying distances from Earth at different times. Thus, it was explained that Earth was not at the exact center of the orbital paths of those bodies, and the varying speeds of these bodies was explained by their proximity to Earth. They moved slowest when farthest from Earth, and fastest when closest to Earth. This idea came to be known as eccentric motion. The Ptolemaic system's greatest strength was how intuitive it was. People on Earth did not feel that the ground they stand on is rotating or revolving. Instead, we see the changing positions of the Sun, Moon, and planets in the sky. Putting the Earth at the center of the universe, with everything revolving around it, seemed like common sense. Despite its intuitive nature, the Ptolemaic system would grow more complex in order to explain a wide range of phenomena. One of these phenomena was planetary retrograde motion, the apparent reversal of the paths taken by planets as viewed from the Earth. To account for this, Ptolemy introduced the idea of epicycles. Each celestial body revolved in a circular path, with the center of each path revolving around the Earth in a path known as the deferent. Thus, there would be times when each body would be revolving along its epicycle in the opposite direction as its general motion along the deferent. This, as Ptolemy explained, was the cause of retrograde motion as perceived from the Earth. Although it was once widely accepted among the scientific community, the Ptolemaic model of the universe eventually fell out of use in favor of newer models. One of these models was Polish astronomer Nicolaus Copernicus's heliocentric model of the universe, intended to be a simpler model than that of Ptolemy. It became a fact that the Earth, along with the other planets, revolved around the Sun. However, Copernicus's model ended up inheriting much of the complexities of Ptolemy's, such as epicycles, in order to explain planetary motion. It was not until the time of Johannes Kepler that the mysteries of planetary motion were finally solved, with Kepler's 3 laws of planetary motion, which described orbital paths as ellipses instead of circles, forming the foundation of our understanding of the universe beyond our world.